So okay everyone, let me discuss about design of electrical lines. Okay, we already discussed about basic introduction of transmission line. Now we will move to some MCQs. So let's start without wasting much time. See first question over here. In a transmission system, if V is the transmission voltage, weight of copper needed is proportional to. So that is the basic question over here. Our answer is 1 by V square. See, in a transmission system, if V is the transmission voltage, you know that V is the transmission voltage, and weight of copper is needed is proportional to 1 by V square. Okay, so this is the basic question over here. In a transmission system, if V is the transmission voltage, weight of copper needed is proportional to 1 by V square. V is nothing but it is voltage. So relation, you have to remember this relation 1 by V square. Okay, now we will move to next question. So V is nothing but V is a transmission voltage. Now see our second question over here. And a blank is a network of electrical components used to supply, transfer and use electrical power. So this is the electrical power system, network of electrical components, various types of components, you know that, to supply, transfer and use of electrical power. See, an electrical power system is network of electrical components used to supply, transfer and use of electrical power. You know that difference in a transmission line, main parameters are L, C and G: resistance, inductance, capacitance and conductance. And this question is asked in a DGVCL JEE 2016. So an electrical power system is a network of electrical components used to supply, transfer and use electrical power. So an electrical power system is network of electrical components used to supply, transfer and use electrical power. The power system is a network consists of generation, distribution, transmission and utilizations. You know that. So generation, various types of generating stations like a thermal power plant, nuclear power plant, okay, conventional type power plant, non-conventional type power plant. And you know that transmission system, primary transmission system, secondary transmission system, primary distribution system, secondary distribution system. Okay, so I already discussed about this primary transmission line, secondary, okay, in a previous lecture. The main advantages of AC over a DC system is, see, the main advantages means merit, AC over DC. See, conversions of flexibility from the one voltage level is another. Yes, very good. AC can be easily converted into DC by using rectifier. Yes, well and good. AC can be easily converted, yes, into DC by using the rectifier circuit. You know that rectifier circuit in a power electronics component. You know basic electronics. Rectifier circuit, single phase, half wave rectifier, full wave rectifier. Okay, and AC is easy to maintain, can be easily distributed at long distance. Yes, good. AC is easy to maintain, can be easily distributed as a long distance. Yes, it will be a good. Okay, so then answer is all of the above. Next, the main advantages of AC over DC system. You know that this is the basic advantage or advantages of AC over DC system. Okay, now we will move to some factual data over here. Just I read. Conversions flexibility from one voltage level. Yes, AC can be easily converted into DC by using a rectifier circuit. I already discussed. AC is easy to maintain, can be easily distributed along distances because AC is high voltage, can be easily achieved. A pure AC signal is represented by the sine or cosine wave. First calculation by, yes, AC signals quantity, sinusoidal quantity, you know that. You know, I can find easily RMS value, okay, form factor, peak factor, and not a sinusoidal quantity. Some you know that triangle waveform, triangular waveform, okay, half wave, full wave, square waveform, like this. Okay, so according to our demand, we can changes, we can rectify some, you know that, if suppose I want to convert in AC to into AC, so by using cyclo converter. Okay, suppose I want to convert in AC into DC or DC into DC. So I'm using some chopper circuit over here, chopper circuit. Okay. Now what is the supply frequency for power supply? 50 Hz. Okay. F is equal to 1 by T. This is our formula. Now we will move to question number 5. Now the volume for copper required for an AC transmission line inversely proportional to both B and C. This is the basic relation over here. P is equal to root 3 VI cos phi. If I want to find the current I, then P by root 3 VI cos phi. If cos phi means power factor increases, then current will be going to decreases. And total copper losses in a 3-phase circuit 3I square R, you know that. And you have to put this value I is equal to P by root 3 V cos phi. Then V is equal to A multiplied by L. This is the what? This is the volume of copper used is inversely proportional to V square cos square phi. So V is the line voltage of transmission line. So what is the volume for the copper required for an AC transmission line is inversely proportional to the both B and C, voltage and the power factor. Voltage and the power factor. Okay. Now we will move to next question. For a transmission of power over a distance of the 500 km, the transmission voltage should be in the range of transmission line range 150 to 220 kV. So you have to remember this factual data directly asked in your examination. For a transmission of power over a distance of 500 km, the transmission voltage should be in range. Range is 150 to 220 kilovolt. Okay. Now the power is transmitted from a powerhouse on high voltage AC because it is a more economical due to less power wastage. Okay, the answer is B. Okay, now we will move to next question. So this is the basic question over here. Secondary distribution is generally carried out by which voltage level? 440 volt and 230 volt. You know the secondary distribution system. So 230 volt is our requirement, consumer requirement. You know that 230 volt is a consumer requirement. So distribution system, the primary distribution is line made by 33 by 11 kV or 11 kV by 440 volt. Primary distribution is distributed by 33 kV, 11 kV, 6.6 kV up to 440 volt. The second distribution carry out by voltage, you know that 440 to 230. Okay, this relation you have to remember. This is a basic question, but sometimes for a transmission of same power, you know that for the transmission of same power, AC line require more copper than DC line. So this is our answer over here. For the transmission of same power, AC line is require more copper than DC. In a DC line there are two conductors required. In a AC line, you know that different types of system over a 3-phase 3-wire system, 3-phase 4-wire system. So our answer is B. AC line require more copper than DC line for same power, for the transmission of same power. 3-phase 4-wire cable, the cross section area of neutral conductor is half of the phase conductor. This is our answer, half of the phase conductor. 3-phase 4-wire cable, cross sectional area of neutral conductor is half the phase conductor. 3-phase 4-wire system commonly use secondary distribution system. This is the important questions, and this question is already asked in SSC JEE 2018. Highest transmission AC voltage in India 400 kV. This is also important question. Okay, which of the following is not a standard transmission voltage in India? 99 kV. Then this is the standard transmission 66, 220 and 33, but 99 kV is not a standard transmission voltage in India. Alternating current is transmitted at high voltage to minimize the transmission losses. Yes, this is the basic question. Next, lower voltage line feeding areas on either side of the main transmission line is called as a secondary transmission line. Okay. Next, lower voltage line feeding areas on either side of the main transmission line is called as a secondary transmission line. This is the basic questions. And you know that according to India's this is a voltage limited up to 10 to 12%. Okay. and change the frequency transmission limit to plus or minus 1.5%, not 1%, plus or minus 1.5%. Okay, you remember this point. If a fixed amount of power is to be transmitted over a certain length with the fixed power loss, then the weight of the conductor required will be inversely proportional to the square of the voltage and that of power factor of the load. Okay, now we will move to next question. See, if a fixed amount of power is to be transmitted over a certain length will be fixed power loss, then the weight of the conductor required will be, see, the weight of the conductor 4 p square rho l square upon v square cos square phi. High voltage transmission efficiency 85 to 95%. Okay, next question. By increasing the transmission voltage double its original value of same power can be dissipated, keeping the line losses 1/4 of the original value. Now, the high voltage line which feeds the substation distribution transformer represent in primary distribution system. High voltage line which feeds the substation. Okay, remember this word, substation distribution transformer represent the primary distribution system. Okay, now the typically voltage of a transformer which is connect the generator output or to the grid is 11 kV by 132 kV. See, typical voltage of transformer which connect generator output of the grid. See, this word is grid. So that is the why 11 kV by 132 kV. Okay, next question. Which of the following statement is not true with respect to an AC transmission system? See, that due to the skin effect, the AC system is effective resistance of line is decreases. This is the not true. Okay, and see, the maintenance of AC substation is easy to and inexpensive. Yes, right. AC voltage can be step up or step down by a transformer with case and efficiency. Yes, this is also right. Now see, due to skin effect in AC system, the effective resistance of line is decreases, not decreases, increases. Our answer is increases. Then this is the decreases. So our answer will be B. See, not true with respect to AC transmission systems. Okay, the answer will be B. B for ball. Then which option represent the correct sequence of the flow of electrical power from the generating stations to the load? See, primary transmission, secondary transmission, primary distribution, secondary. You have to remember this. Okay, pattern you have to follow this: primary transmission, secondary, then primary distribution, secondary distribution. Very easy question. See the line diagram. Three-phase balance system working at 0.9 lagging power factor, line loss 3600 kilowatt. If power factor is reduced by to 0.6, then line loss. Most important question. See, the relation, that line loss is equal to 1 by cos square phi. Then you have to take the ratio line loss and power factor cos theta by 2, cos theta 2 upon cos theta 1. Okay, now write these values and you have to simplify this equation. Then our answer will be 8100 kilowatt. See, basic relations. You have to remember this basic relation. What are the advantages of DC transmission system over AC transmission system? See, the DC transmission system is economical for long line. Okay, there is no skin effect in a DC system. Yes, corona limits are negligible. Yes, for DC circuit. Okay, well and good. So our answer will be all of the above. Voltage under extra high voltage are 132 kV and above. Low voltage, this is the low voltage, and high voltage over here you can see that high voltage and low voltage. Then AC transmission system, the load current is inversely proportional to the power factor. Okay, see, this is the basic question over here. Which of the following voltage level is used in primary transmission line 132 kV? Okay, now you can see that which of the following has to be considered overhead underground electrical power transmission distribution system? See, the voltage consumer per mesh, yes, plus or minus 4 to or plus or minus 6 of the declared the voltage. Then the insulation resistance of the whole system should be very high, and loss of power system itself should be small percentage, about 10% of the power transmission. Okay, this A, C and D is right. Next question. Advantage of cable overhead line is can be used in congested area. In a highest AC transmission voltage used in India, 765 kilowatt. Which of the following is the main advantage of transmission power over a transmission line on high voltage? Efficiency of transmission line is increases. In a transmission system, feeder feeds power, or answer feeder feeds power to distributor, or answer is distributor. Not a standard transmission voltage, 222 kV. Three-phase system is universally adopted for a generation, transmission, distribution of electrical power. Three-phase, okay. Long distance, kilovolt. Long distance line voltage measured in kilovolt. 600 kilometer underground power transmission system. Base transmission system is DC transmission system. Okay. 60 kilometer underground power transmission system. Base transmission system is DC transmission system. Three-phase AC supply system compared to single-phase AC supply system has the advantage of high efficiency. Advantage is high efficiency. Answer is B. What is the main consider for a higher and a higher operating voltage of transmission system? To increases the efficiency of transmission and reduce the power loss. Very basic question. The transmission line feeding power or either side of the main transmission line is called as a secondary transmission line. Okay, the transmission line is feeding the power on the either side of the main transmission line is to be called as a secondary transmission line. Okay, now the transmission lines which feed different substations represent secondary transmission line. Okay, do not the confusion about this question. The transmission line which feed different substations represent the secondary transmission line. Represent the secondary transmission line. Transmitting power at high voltage require more maintain the protection of the equipment, faster control the minimizing the arcing of the contact, larger control the minimizing the arcing of the contact. Okay, the answer will be D. Okay. 66 kV is suitable for transmission of power over is 60 kilometer. Okay. Power is to be transmitted over a large distance, any 200 kilometer. The requires the transmission voltage must be very easy question, 132 kV. Three-phase transmission line transmission efficiency increases when the line voltage increases. Answer is A. Transmission system, the cost of lost energy is inversely proportional to the square of the voltage. You know that. This relation, you have to remember this relation. Which of the following is a type of distributor system according to nature of current? The answer is AC distribution system. Okay. So we have discussed 47 question. Okay. Then other question will be discussed in next lecture. Okay. Thank you very much.